theorem 9.7. And this is properties of infinite series. I'm not going to go through all the details at the beginning because you guys have that from this section, like the let summation a sub n and summation b sub n be a convergent series. You guys can read through that part. It's just important that since they're a convergent series, n equals 1 to infinity, if you have a constant, so like c times a sub n, that's the same thing as saying c times the value that they equal. So like you could pull c out, find the summation, and then multiply by c afterwards. 2 summation of n equals 1 to infinity of the two different series add together. You could take their actual values and just add them at the end. And then summation of n equals 1 to infinity. If it's subtraction, it works the same way. I always don't understand why they just don't put plus or minus and do it there, but whatever. Okay. Then you have theorem 9.8. And this is called limit of the nth term of a convergent series, because they're like, hey, we need to have the longest name possible. Yeah.
What is so back at where number 1 is, it says a to the n. What's in front of it? Is that a c?
Yeah.
Or
okay. Like so some constant.
Okay.
All right, and here if the summation n equals 1 to infinity a sub n converges, then the limit as n approaches infinity a sub n equals 0. All right, the good news is there is a limit of the nth term of convergence, but there's also one for divergence, so that way you have some clarity.
Oh, I wasn't paying attention.
Oh, my
page.
Bad. No, it's okay. I'll wait. Un memento.
Like, no.
It's all good.
And Bailey, it's also in the textbook. I'm following along in the book too.
Yeah.
Okay, well, the book, like, when I was trying to look at it yesterday, I got very overwhelmed, and I was like, I'm just gonna...
Yeah, it's all good. Like, looking at the book sometimes is scary, because there's just so much information at one time. You're like, oh.
Because you were saying, look at this problem. I mean, you don't really have to, but you can. And then I was like, where is it? I can't find it. So.
Yeah, it can get a little bit overwhelming, for sure.
Okay, limit. Oh, is that not? Oh, nth. I was like, what is the nth term? I don't. Why does it have to be this long?
Because they're going for the longest theorem name in the textbook.
Got it.
Record.
Yeah.
So now we're going back to infinite series, so this isn't geometric anymore.
Correct.
Well, that's annoying.
I agree.
Oh, did you guys see Miss Walker's email? I was dead.
Oh, she said, good morning. Please rise. Okay, then the limit of infinity a and okay. You're good.
Okay, cool.
Oh, wait, I think someone said no.
Did someone just yell no?
No,
I think...
I was just stretching.
Oh, okay. I was like, I'm sorry.
That was Lily. I knew exactly what she was doing.
I didn't know if she was stretching or saying no.
It sounded, on my end, it was like distant, and it sounded like, no.
I was the first person to yell no earlier, but this time I was just...
It's all good. Okay, so we have theorem 9.9. And that is the nth term test for divergence. And this is a lot more basic. If the limit as n approaches infinity of a sub n cannot equal 0, then the summation as n equals 1 to infinity of a sub n diverges. Probably should be a comma there. Just maybe. Okay, so we have a couple example problems we can talk about. Determine if the series converges or diverges. All right, so you have A, which says the summation as n equals 0 to infinity of 2 to the nth power. And we'll look at B and say the summation of n equals 1 to infinity of 1 over n. Okay, so this is one of those things where you can use both properties again. So,
So you can use the geometric thing?
Right, you see this, and you could do the nth term of convergence test, but you could also go, hey, my R value, R, is greater than 1, or greater than equal to 1. So it converges. If you take the limit equals 0, or cannot equal 0, it's going to go to infinity. So it also, sorry, I meant to say diverges. I'm over here writing the wrong thing. I said it at first, then I wrote it wrong. Dope. Okay, so you could, this is one of those things. You can use the geometric property again. Now, for part B, you want to use their new limit idea. So with this, you want to think about, okay, well, what's the limit as n approaches infinity of 1 over n? And this is one of those things we've talked about several times. If I keep plugging a number into n, I'm converging to what, or I'm going towards what number?
Wait.
If my fraction, if the denominator just keeps getting larger, 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 and larger, like if I say 1 over infinity,
Going towards 0?
I'm going towards 0, right?
Yeah.
So it converges.
What theorem did you use for that one?
That's the nth term one, like 9.8. And that's strictly because if you just take the limit, you can see that it goes to 0.
So this is kind of the same thing we were doing yesterday.
Yeah.
But just with theorems.
Yeah.
So they're saying the same thing.
Yes.
Awesome.
Okay.